This video is on modeling exponentials. We're going to be looking at a problem about Bangladesh. Bangladesh's population in 1950 was about 42 million people. So we know that our starting time in 1950 was about 42 million people. Over the last 60 years, the population has continued to grow. It grows about 2 4/10% each year. So let's think about that. We don't ever want to see a percentage. We have our starting value of 42 million people, but we need to know our factor, not our rate. So 2.4 to 2 4/10% is a rate. So we want to take our value here of 2 4/10 and rewrite that as only a decimal by moving our decimal value twice to the left and adding zeros in the spaces. This gives us 0.024 as a decimal. Now, since it is a growth, we're going to do b equals 1 plus the 0.024. We need to make this 1.024 as our growth factor so that we can actually do our equation later. So 1.024 is our growth factor. So let's complete the table for Bangladesh's population for the following years. So years after 1950 is going to be, so 0 years is we have 42 million people. So this is population in millions. We're just going to put the number 42 in here. So it grows at 2.4% each year. Notice that after 5 years, it's asking for 5 years, not after 1 year. So we're not just going to multiply by 1.024. We need to use the equation to help us figure this out. So it's going to multiply by 5 times of that. So if we were to get our equation, we can use the equation to help us. So let's look at the equations as well. Every year, it's going to increase by 1.024 as a multiplicative factor. So write a rule, y equals, so y equals 42, parentheses, because that's our starting value. Our growth factor is 1.024, close parentheses, and we're going to raise it to the x power. So with this, we can use our equation to write a now next rule as well. So to find the next value, we will take our now value and multiply it by 1.024. But we have to start at 42 million. So in order to complete this table, we cannot just multiply 42 times 1.024. We have to make sure that we know that it's after 5 years of doing this. So it's not after 1 year. So I'm not just going to multiply by 1.024. I'm going to multiply by 1.024, and then that by 1.024, and then that by 1.024. So I would have to keep going until I get to the 5th one, then the 10th, then the 15th, then the 20th. Or we can just use the 5 as the years after 1950 to write it in here. So we want to make sure that we know that x, I'm going to write a little note on here, x is years after 1950, because that was our starting year. So 5 years after 1950 would be 1955. So when we plug that in, we will get roughly to the nearest hundredth, or to the nearest tenth, 47 3/10 million people. If we do the same thing, but with 10 years after 1950, so at 1960, we should get 53 2/10 million people. If we raise it to the 15th power, we would get 59 9/10 million people. And then if we raise it to the 20th power, we'd get 67 5/10 million people. So again, it's very important that you're reading carefully the table. If this had just said 0, 1, 2, 3, I could just multiply by 1.024 each time. But because we're going by 5, 10, 15, 20, we have to make sure we use our rule to help us. So describe the pattern of change for Bangladesh's population. So we know that it's growing by a factor of 1.024 each year. And that's actually what we'll write. The population grows by a factor, because remember, B is our factor, our growth factor of 1.024, or it grows at a 2.4% rate each year. So we're going to multiply by 1.024 every year to show that it's growing. What was the estimated population for Bangladesh in 1980 and then also for 2000? So in 1980, we need to know how many years after 1950 that is. So 1980 is 30 years after. So x would equal to 30. So if we were to plug this in, we'd have y equals 42 million times 1.024 raised to the 30th power, because that's 30 years after 1950. This gives us approximately 85 6/10 million people. So for 2000, the year 2000 is 50 years after 1950. So that's x is equal to 50. So if we plug that into the equation we have, or we could finish the table, y is equal to 42 million times 1.024 raised to the 50th power. And this would give us approximately 137.5 million people in 2000 in Bangladesh. Again, estimated. When will Bangladesh's population reach over 200 million people? So this is really 200 million. So we have 137 million here. So instead of us saying 200 million written out like this, we would actually write this as the y value would need to be 200 because we're already in millions. So if we were to graph this, or using our table, we would use y is equal to 200 and y is equal to that 42,100,1.024 raised to the x. So when we find this, x would be approximately, x after approximately 66. So it would be after approximately 66 years. So this would be around, so 66 years after 1950 would be around 2016. So it would reach over 200 million. So I'm just only going to use the 200 and find where it crosses the 42 times 1.024 raised to the x. Also looking at the table, if we had kept going with this, we could keep going with the, we know it's after 50 because we're at 137 million at 50 years. So if I kept going, we could get at around 66 years is when we would have over 200 million. What does f of 39 equals 105 9/10 mean in the context of the situation? If we remember, this is supposed to say f of x. This is really x value, and this would really be the y value. So x is 39. X is, remember, the years after 1950. So after 39 years, which would be in 1989, the y is the population. So the population is about, because it's not going to be exact, we have 105 and 9/10, but it's in millions people. So 39 is the X value, which is years after 1950, so that'd be in 1989. Then the Y is the population of Bangladesh. The population is about 105 and 9/10 million people in Bangladesh. And that's how we put it in context.